In this video, we are going to apply superposition principle to another circuit having one voltage source and another current source. So the concept is here I have considered two different sources. One is voltage source, the other one is current source, right? So now I want to find the current flowing through I9. So I9 is the current flowing through 9 ohm resistor, that is R2. So according to superposition theorem, I have to consider one source at a time by replacing the other sources with their internal impedance. When I am considering the voltage source, 3 volts voltage source, I am replacing the current source with its internal impedance. Internal impedance of this source is not given, which means it is infinity. Infinity means open circuit, so there is no connection between these two terminals. Now, in the second circuit, or else in the last circuit, I considered only the constant current source. I didn't consider the voltage source. Rather, I replaced the voltage source with its internal impedance. Internal impedance of this is not given, so you have to consider that as 0. Remember, if the internal impedance of the voltage source is not given, you have to replace that with a short circuit. If the current source is not given, internal impedance of the current source is not given, you have to replace that with its internal impedance. It's not given, so open circuit, nothing but infinite impedance, like this, right? So now, according to superposition theorem, the current that is flowing from B to C is I1 by considering this source alone, and in this the current flowing through this is going to be in this from B to C will be Ix. In this it is I1 from B to C, in this it is Ix from B to C. So according to superposition theorem, I9 is equal to I1 plus Ix. So I'll find I1 value like this by applying KVL in this mesh. Applying KVL in A, B, C, A, we get I1 into 6 plus 9 into I1 minus 2 plus is minus 3 is equal to 0. So I1 is going to be zero point 0.2 amperes. 0.2 amperes. Now the next one. Now, in this circuit, I consider the current source alone. I replace the voltage source with a short circuit. So now that I want a current in R2. So the formula for that is Ix is equal to, Ix is the current flowing through this. Ix is equal to, total current is I1. I1 into R1 by R1 plus R2. This is the general formula which we use in order to find the current through a single resistor. Through a resistor, if two resistors are in parallel with each other and there is the whole arrangement is in parallel with a current source like this. If you see something like this, then you can directly use this formula in order to find the current in a particular branch, or you can apply nodal analysis also. But nodal analysis is a lengthy process now, so you no need to apply nodal analysis now. You can use this shortcut principle or shortcut formula in order to find the current in this branch. So that is going to be, total current is 2 amperes, R1 value is 6, and R1 R2, R1 is 6, R2 is 9, so 0.8 amperes. So the current from B to C through 9 ohm resistor is 0.8 amperes. So according to superposition theorem, so the current from B to C is the sum of the current by considering one source at. By considering this, I got the current from B to C as 0.2. By considering current source alone, without considering this, the current through this resistor is 0.8. So the total current is going to be 0.2 plus zero point 0.8. So I1 plus Ix, that is zero point 0.2 plus zero point 0.8, that is 1 ampere. I have simulated the same circuit using the PSpice simulator, and the result that also is showing me as 1 ampere. 1 ampere is due to both the sources, but the contribution of this particular source alone is zero point 0.2 amperes. The contribution of this source alone is zero point 0.8 amperes. The total current that is flowing from B to C through 9 ohm resistor is 1 ampere. So like this, you can apply superposition theorem in order to get the required parameter little more easily without even applying any other difficult techniques or complicated techniques. So directly. So the next one is source conversion. Source conversion, uh, a given voltage source. This is one of the shortcut technique, shortcut method or a shortcut technique where you can apply whenever there is a requirement for this conversion. Okay, so according to this, a given voltage source series resistance can be converted into a constant current source in parallel with resistance. Means if you see something like this voltage source and resistor, you can convert that into current source in parallel with this resistor. You can convert this into this into this. Voltage source in series with resistor as current source in parallel with resistor. So here, while converting the voltage source into the current source, you need I value. I is equal to V by R. This R after the conversion also will remain same, right? So we will apply this concept on this network. You see here A to C, there is a voltage source which is in series with a resistor of 6 ohms. So you can replace this entire thing with a constant current source in parallel with the resistor. So the value of this current source is I is equals to V by R. V by R. How much is that V? How much is that V? V is 3 volts. V is 3 volts and R is 6 ohms. R is 6 ohms. So I is equal to V by R, that is 0.5 amperes, and this resistor value is same resistor value. So using this source conversion technique, you can convert voltage source in series with resistor into current source in parallel with the resistor. What is the purpose of this? Is mainly to reduce the complexity of the network or to arrive at the requirement very easily. And similarly, constant current source. Here there is a constant current source and this is in parallel with the resistor. This can be converted into a voltage source in series with the equivalent resistance. So the value of V is, so here resistance remains same. Resistance here is series, here it is parallel. The value will remain same, but current source will not be there. That will come in series with the resistor as voltage source. The value of that voltage source is going to be V is equal to I into R. I is 2 amperes, R is 9 ohms. V is equals to IR. 9 into 2, 18 volts. So this is how we can convert the given source, voltage source into current source into voltage source. You can apply this particular source conversion in reducing the complexity to arrive at the network parameters very easily. So after the completion of this video, student will be able to understand what is the superposition theorem and how to apply and when to apply, and on a bilateral network, even that is a linear network, and how to convert the voltage source into series, voltage source into the current source and current source into the voltage source in order to get the required parameters little more conveniently, easily. Thank you very much.